Hi, welcome to today's video. We are going to kind of talk more about quantifying predictability, working with our scatter plots, our data sets, and just taking it a little bit deeper, just learning more information about it and all the information that it can supply for us. So, we've talked about creating lines and lines of best fit for bivariate data, our scatter plots, okay? No, remember that the data did not always fall on a perfectly straight line or that perfect curve, but we never talked about how close it is to a linear equation, okay, and something called predicting the correlation between the two variables, like how strong that correlation is, okay? We've kind of talked about positive, negative, or none, but today we're going to talk about exactly how strong that is. So we're going to start with our graphing calculator. So if you have a graphing calculator, go ahead and pull it out and follow along. Regardless, follow along because we're going to do this in class the next time you see me. So I'm going to pull out my graphing calculator. Here it is. I've just reset it just so it's good to go and should be similar to yours. So what we're going to do first is we have to, since we're finding correlation coefficient, make sure it's working on the calculator. For some reason, it's always defaulted to turn off, so we're going to turn it on. We're going to go to this catalog, so we're going to hit second, catalog, and we're going to go to something called diagnostic, so we're going to hit D. We see the alpha is turned on, so we'll hit D. We're going to scroll down to diagnostic. And we're going to turn it on, so we're going to hit enter. We're going to hit enter again. Now it's on. Okay. The next thing we're going to do is since we're working with statistics, we're going to go to stat. We're going to edit. So we're going to enter information for table 1 into our calculator. Here, L1, L2, these are called lists. We're going to make L1 our X values. So just 2, enter, 5, enter, 8, enter, 11, enter, 15, enter, and 18, enter. So there is list 1. List 2 are Y values. 4, enter, 13, enter, 22, enter, 29, enter, 43, enter, and 52, enter. So there is our Y values, okay? Now we're going to do some calculations with this. So we're going to go ahead and go to stat, calculations over. Something called linear regression. So what I want you to notice, look, it's AX plus B, which is similar to MX plus B. So there is a connection there. Tells us, it picks out automatically, well, your X must be L1, Y must be L2. Yes, that's how we put it in. So we're going to go down to calculate. So I just scroll down, we hit enter, and it does it for us. So what's really cool is it actually gives us our slope. So there it is, our slope. So we could write a linear equation. Here's our starting point, negative 2.2. R squared, but more we're interested in something called R. Okay, R is going to be our correlation coefficient. That's what we're going to write down for part A. So R, and we're going to round to the thousandths. Okay, so here, coming back, they're all positive correlations. Notice that we have that positive slope. We're recording the R value to the thousandths. So 0.999, okay? So our goal is, and we'll write this down a little bit, closer to 1, the stronger we have as our correlation. So we will go ahead and say that this is a strong, positive correlation. Okay. Now, if I wanted to, I could go ahead and take a look at what this looks like on a scatter plot. So I'm going to go to stat plot. So second, stat plot. I'm going to turn it on. So enter. Oops, sorry. I hit enter. We're going to turn it on. And then we'll go to graph. We don't see very many points, so I'm going to have to change the window. I don't need negative X values, so I'm going to put 0. Same thing with Y. I don't need negative Y values. What I notice on my table, my highest X value is 18. So I'm going to do my X max as 20. My highest Y value is 52. So let's do Y max is, let's say, 60. Then graph. And there it is. You see it's almost in that straight line. So it's a very good fit, strong positive correlation. Okay? Let's go ahead and do C. Okay, so for C, what I'm going to do is I'm going to go back and edit my list. So I don't need second. Stat. We're going to edit. So hit 1 or enter. My X values are the same. It's just my Y values that change. So I can just type right over 18, enter 8, enter 41, enter 28, enter 62, enter 44, enter. There we go. Okay, I'm going to go to stat. We're going to calculate. I think I hit the wrong calculate. I'm sorry. Calculate, we're going to go down to 4, linear regression. Here we go. And go all the way down to calculate. And again, we have y equals ax plus b. There's my slope. There's my starting point. And we're looking for the r value. So my r value, rounded to the hundredths, is 0.7763. Went a little too far. There we go. And so this is not as close to 1. And let's take a look at that scatter plot. It's on. And all I need to do is go to graph. Sorry. So here's my graph. This y value is not on there. So I can go to my window and change this. Let's make this maybe 60. We'll make it 70. Now I go to my graph. I have all my points. This is not as close to that straight line as before. So what I would say for this one, you know, we are observing the scatter plot. We recorded the R value. Let's write down our observations. So we're going to go ahead and say, so again, looking at that, this is a poor fit. Okay, very scattered. And again, our goal, we will say closer to 1 or negative 1, the better fit. I'm trying to think of how I want to word this. The better the fit our data. The better the fit our data or the data. We'll have the. Okay. We'll do B and D in class. Again, just practicing with that graphing calculator. So how does the correlation coefficient quantify the fit of a positive correlation? So this one is more specifically a positive correlation. So the better the fit, and we're talking about a linear line, so we'll go ahead and call it the better the linear fit, the closer the R value is to 1. So the opposite is true. The closer, the poorer the fit, the closer it is to 0. Okay, so again, the better the linear fit, the closer the R value is to 1. The poorer, I know I kind of squeezed that in there, can't seem to write. The poorer the fit, the closer the value is to 0. Okay? For exercise 3, this is another one. This is talking about negative correlation, and we'll talk about how the closer to -1, the better the fit it is for negative correlation when I see you guys next time. So we'll talk about that next time. Let's flip it over and we'll be getting some of them done here on the back. So given the scatter plot shown, which R value would most likely represent the correlation between the two variables? So the first thing I'm going to notice is right here I have a positive correlation. So 4 I'm going to cross out because that is for a negative correlation. The other thing that I notice is that it would probably not be 3. It's not going to be 3 because it's not exactly a straight line. It is just not that close 2, it would be much looser, probably closer to number 1 or number 3 down that I'm looking right here, okay? So my answer is going to be 1. So this is a good fit for our line of best fit. It's not perfect, but it's not that bad, okay? So again, that's why our answer is 4. Now, number 5, which of the following scatter plots would have a correlation coefficient closest to -1? So this time we're talking about a negative slope, okay? So we're going to cross out 1 because that's positive. We are going to cross out 3 because this is pretty much no correlation. So our choice is between 2 and 4. So which one is closer to -1? 2 we will call a poor fit. 4 is considered a strong fit to -1, okay? And the last one, we'll just get started on this one. There are 2 primary types of crude oil sold in the world, West Texas Intermediate and Brent crude. Each is priced differently on a daily basis, and each has a correlation with the average price per gallon for unleaded gas. The 2 linear regression models, okay, so these 2 equations, this is what we saw on the graphing calculator, where it can give us the M and the B, and on the graphing calculator was A, along with their R values are shown. So this is straight from the graphing calculator. We're going to give a prediction for the price per gallon of unleaded gas Y on a day when the price is 103 and the price for Brent is 109. Which model do you choose and why? Okay, so for Brent crude, what we're going to do, we're going to use the slope that they give us. We're going to substitute 109 in and simplify. We're going to do the same thing for WTI crude. Substitute was 103. And we are going to start simplifying, okay? So it asks which model we would choose and why. Something to think about is which model is closer to 1, okay? And then we'll go from here and we'll just wrap this problem up the next time I see you, okay?